Welcome everyone. In this video, I want to go to do the second part of the sample final. Please watch my last video. I did the first 5 problems and I explained those now. Let's continue, and then we're gonna probably do 5 more in this video, and then I can make another one for the last 5. So let's go to number 6. So let's see, number 6 says solve 2y triple prime plus 3y double prime minus 3y prime minus 2y equals to the power of negative t. Given those conditions using Laplace transform, make sure to check the lecture on Laplace transform. So the details, so you can check them out, the details in that in those videos or the lecture notes. But let's solve this problem, see how we can use them. Now, we substitute y triple prime, so it's 2 times, you know that's how you write it. You start with, if it's triple prime, s cubed times y of s minus s squared times y of 0 minus s times y prime of 0 minus y double prime of 0 plus 3 times, then it's the second derivative, you start with s squared times y of s minus, and now it's going to be s times y of 0 minus y prime of 0. So stop at y prime of 0 minus 3 times y prime. So minus 3 times again. If it's y prime, you just write s times y of s minus y of 0 plus. And if it's y, you just write y of s. And you know that Laplace transform of e to the power of negative is 1 over s plus 1. Please check those. Then our goal is to isolate y of s, and if you use the conditions again, we know y of 0 and y prime of 0 are 0. So these are just times 0, and that's 0. And if you substitute the zeros, then you get a smaller expression on the right side. And again, use some algebra, factor out y of x, and you're left with 2s cubed plus 3s squared minus 3s minus 2, and you take that 2 to the other side. You can find the LCD on this side, which is s plus 1, so it's 2 times s plus 1, and you divide both sides by this expression, and finally you get 2s plus 3 over that. Now, how to factor this? It's you can use synthetic division or technology. It's completely all right. Once you write this, then you have to get the partial fraction decomposition. So to get the partial fraction decomposition, you can also use technology for the long ones. That's completely all right. And in the next problem, I do that very in detail. So kind of to show you, but I do have a recording on that also, please watch. So the partial fraction decomposition of that is going to be 1 over 2, 1 times 1 over s plus 1, 5 over 18, 1 over s minus 1, minus 8 over 9 times s o plus 1/2, 1 times plus 1 over 9 times 1 over s plus 2. Let's get the Laplace inverse of each one. So 1 over s plus 1 is e to the power of negative t. We have the 1/2, 5 over 18, 1 over s minus 1 is e to the power of t, minus 8 over 9, and 1 over s plus 2 is e to the power of negative 1/2 t, and this is 1 over 9 times 1 over s plus 2, and you know for 1 over s plus 2 you can write it to the power of negative 2. Make sure to watch the recordings and the tables for Laplace transforms. Number 7, same thing we have to do. However, here we have t times y prime. Now there, I put the note for you, and again, it's in the lecture notes and the video of the Laplace transform. So if you have t y prime, you can take the first derivative of L of y prime, and that's going to be the verb minus the first derivative of, and y prime, we know we can write that as s times y of s minus y of 0. Y of 0 is 0. And just to take the derivative, you can use the product rule. So it's s times dy ds. So plus the derivative of s is 1 times y of s. So that's what we have. Now we can go to the original equation and substitute. 2y double prime can be written as s squared y of s minus s times y of 0 minus y prime of 0. For that, you can just use that expression, negative s dy ds minus y of s, and negative 2 times y is negative 2 times y of s, and the Laplace transform of 10 is just that constant over s, which is 10 over s in this case. Now, we notice that here we get an equation and we want to solve for y of s in this case. So because we have, that's a differential equation itself. So if you divide everything by s, then what you get is a linear system or linear equation, differential equation. And you know that linear differential equation, and then you put the e here, you solve that by using the integrating factor. So in this case, please check the first module on linear differential equations. The integrating factor is e to the power of p of x dx, but in this case is p of s. So it's that. You can take the integral of that. So it's negative s squared plus the integral of 3 over s is ln s cubed. Now you can separate those and write e to the power of negative s squared times e to the power of ln s cubed, which is just s cubed. So then, as we know, the product rule applies here. So what we have is the left side becomes the derivative of s squared, s cubed minus e to the s squared times y of s. Now, if you want to solve this, you have to take the integral of both sides. This is a derivative, so the integral is the same thing, stays, and then you can take the integral of that. You can do a u substitution. So this is just e to the u du, where u is going to negative s squared. So if you do that and you take the integral, you get 10 over 2 e to the negative x squared plus c. Isolate y of s, and that's simplified. So we get phi over s cubed plus c over s cubed e to the power of negative x squared, but it's that one. Now c must be 0 because in this case, the limit as s approaches to infinity of y of s has to be equal to 0. So this is going to approach to 0. No problem is that this doesn't approach to 0. The only way for that to be possible is c to be 0. So our constant is 0 here. So you get y of s is 1 over s cubed. And again, the inverse of that is pretty straightforward. It's going to be 5 over 2t to the second power. And that's the answer. Next, find the inverse of that. So again, in those cases, you have to do the partial fraction decomposition. And this one, I try to do it for you step by step. So again, for s squared, we can write a over s plus b over s squared. Then we have s plus 1 cubed, so plus c over s plus 1 plus d over s plus 1 squared plus u over s plus 1 cubed. Finding the LCD, and we multiply a by s. LCD is just that. So this one we multiply by s and s plus 1 cubed plus b times. This has s squared, so you multiply b by s plus 1 cubed. This one has s plus 1, so c times s squared, s plus 1 squared. This one has s plus 2 squared, so it's d times s squared has s plus 1. And this one has s plus 1 cubed denominator, so you can, that's what you're missing, so you multiply e by that. You can put the numerators equal to each other because the denominators are going to cancel, and that's what you get. Now, if you open those up and try to equate the coefficients on both sides, then it's going to be pretty long. But let's see how we can do this by inspection. So here, the main numbers are 0 and 1. If you let s equals to 0, then all the terms, first of all, here you get -1, and all the terms here are going to cancel except that one. So you get b times 1 cubed, and on the left side you have -1. So b, you can get b very fast. Now if you come back here, instead of b, write that number, and now say s equals to -1. If you do that, all these cancel except this term. So I put it here for you. 2 times -1 minus 1 is going to give you just e, so you can solve for e, which is -3. So a couple of those constants are solved very fast. Now, how else we can kind of do this? What you can see is, let's see the ones, the power, when s is 4, you just have it in this term. S times s cubed is going to give you s4. So you know that the coefficient of one of the s4 is going to be a, and the other one c times s squared, and here you have s plus 1 squared. If you open this, so you're going to have another s to the 4th power, and the coefficient is c. Now we know that if we add, and we go back here on the left side, we don't have any term with s to the 4th power. So obviously the coefficient is going to be equal to 0. So you can say a times s to the 4th power plus c times s to the 4th power equals to 0. That means a plus c is 0. So a equals to -c, or c equals to -8. So you can remember that. Then you can go ahead and write 2s minus 1 and write a here, and for c write -8. So you get what we want to solve for is a and d. You can let s to be any number here, and the easiest one that I thought of was 1. So if you do that, then you are going to get a relation between a and d is 6 minus 2a. So now you go back here, instead of d, you can substitute 6 minus 2a. So as you notice, we're just left with a. So what you can do is pick another simple number and substitute s by that number, and that's what I did. And if you simplify everything, then you're going to be left just with a. So you can solve for a, and a is 5. Now it's easy. We have a, we found b, and we know c is -a, so it's -5. And we know that d was 6 minus 2a, so it's -4, and e was -3. So the Laplace inverse of that expression is the Laplace inverse of that. And then let's get that 5 over s is 5, 1 over s, -1 over s squared, so it's -t. That's going to be 5 times e to the power of -t. That's going to be 4 times t e to the power of -t. And that's going to be 3 over 2, and that's cubed, so t squared e to the power of -t. That's the answer. This one is the same type of problem. So partial fraction decomposition one more time. If you want to use technology for that, that's not a problem. You can do that, because here is not the algebra, but you need to know how to use the Laplace transform. So if you find the partial fraction decomposition, I just got it and wrote it for you. So that is 2 times s over s squared plus 1 plus 1 over s squared plus 1 minus 2 times s over s squared plus 4, and minus 1/2 times 2 over s squared plus 4. This is cosine t. That is sine t. And this one is 2 cosine 2t, because that's 4. And of course, this one is going to be minus 2 sine 2t. So that's the answer. Next one, find again the Laplace transform of that. So, and we call that the Laplace of f of t over t is equal to the integral going from s to infinity f of s ds. Make sure to watch the lecture on Laplace transform. Let's see how we can do that. So if we write that, first of all, can write that as 2 over t and cosine kt over t. So we can separate that. Take a dummy variable here. So what you need to do is find f s going the integral s from s to infinity. So you're going to get 2 over u. And again, for cosine kt over t, you get 2u cosine u squared plus k squared. Take the integral, that's going to be ln 2 ln u minus ln u squared plus k squared. So that's just du over u. And you can take the integral is just ln, and then you can change that to ln u squared. So we're just using properties of ln from now. And when you subtract, you know you divide. So it's 1 ln and u squared over u squared plus k squared going from s to infinity. Now, limit as u approaches to infinity of that expression is 1. So again, it's the coefficient of the leading terms because they are the same. So it's 1 and ln 1 is 0. And then for this one, you just substitute u by s and you're left with negative ln s squared over s squared plus k squared, but you can flip this fraction and then get rid of the negative sign. Both answers are good, and this is 0. So the answer, you can write that as negative ln s squared divided by s squared plus k squared, or simply ln s squared plus k squared divided by s squared. So we did number 10. I think I should stop for this video, and then the next one I can do the last 5. So total we can have 3 solution videos on the sample final. Thank you for watching, and I'll see you in my next video. Have a good one.